another look of rational exponents, and this is x to the power of m over n. So now we have a rational number uh, as an exponent where the numerator is not equal to 1. So there's two operations that is undertaken. It's the nth root and then raising to the power of m. So what we could do here is, let me just briefly talk about path number 1. And please don't take path number 1. It's much, much more difficult. So our base is x, and we could raise x to the power of m and then take the nth root. This ends up to be problematic. So if x is 3 and m is 5, that would mean that we'd have to raise 3 to the power of 5. Now 3 times 3 times 3 times 3 times 3 is actually an extremely large number. I would surely get lost in the math, and let's look at a far easier way. The better way to do it is to take the nth root of x first. So my base is x, so that becomes my radicand, and my index is the denominator of my rational exponent, just like what we've seen earlier. However, now m ends up being our exponent. Let's take a look at some examples. Let's write 8 to the power of 5 over 3 in radical form, then evaluate. So 8 to the power of 5 over 3, what we see here is we get the index of our nth root, so this is the third root, from our denominator of our rational exponent. Then our exponent 5, or to the power of 5, comes from the numerator. So this is in radical form. So I'm going to work in order of operations. I'm going to evaluate what's in the brackets first. The third root of 8 is 2. 2 to the power of 5, well, that's 2 times 2 times 2 times 2 times 2 is 32. Let's do another example. Write 243 to the power of 2 over 5 in radical form. Then we're going to evaluate. Please don't get scared as the numbers get big. This will probably simplify into an integer value. I'm certainly hoping anyways. So I'm going to change it to radical form. So I'm looking for the fifth root of 243 squared. Notice that the denominator becomes my index of the root. The numerator becomes the exponent of my radical. So what number multiplied by itself 5 times gives me 243? 3. So I simply evaluate what's in the brackets first. That is 3. 3 squared is 9. So 243 to the power of 2/5 is 9. Now, on an interesting side note, our exponent can also be a what you guys would call a decimal number. So 243 to the power of 2/5 can also be written as 243 to the power of 0.4. 2/5 is 0.4. Now I am going to write 1000 to the power of 6 over 3 in radical form that I'm going to evaluate. So if I continue without thinking, really, the denominator, in the exponent, the denominator of my exponent becomes the index of my radical. The numerator of my exponent becomes my exponent of my radical. So what number multiplied by itself 3 times gives you 1000? We're going to evaluate what's in the brackets first. 10. 10 to the power of 6 is 1,000,000. Let's take another view at this. I'm sure some of you may be scratching your heads and had a thought like, could we not simplify this exponent since 6 divided by 3 is 2? Well, let's see. 6 divided by 3 is 2. That's 1000 squared. 1,000 squared ends up being a million. And in fact, you can simplify, if you ever are able to, please simplify your